Data science and data analysis are two closely related fields that play a significant role in understanding and interpreting information. Data analysis focuses on examining data sets to uncover patterns, trends, and insights, often using statistical methods and visualization techniques. In contrast, data science encompasses a broader scope, combining data analysis with machine learning, programming, and domain expertise to solve complex problems and make predictions. While both fields rely on data, data science often involves building models and algorithms, whereas data analysis is primarily concerned with interpreting existing data. Understanding the distinction between these fields helps organizations choose the right approach for their specific needs and challenges. Data scientists play a crucial role in transforming raw information into actionable insights. Their work often involves building predictive models that can forecast trends or behaviors based on historical data. By leveraging machine learning techniques, they enable systems to learn from data and make decisions with minimal human intervention. Deploying AI systems into real-world environments is another key responsibility, ensuring that these solutions operate efficiently and securely. To accomplish these tasks, data scientists commonly use tools such as Python, R, TensorFlow, and scikit-learn, as well as platforms like Jupyter Notebook for experimentation and visualization. These tools help streamline the process of data analysis, model development, and deployment. Ultimately, data scientists bridge the gap between complex data and practical business solutions. A data analyst plays a crucial role in transforming raw information into actionable insights for organizations. Their work often begins with data cleaning, where they identify and correct inaccuracies to ensure reliable results. Through statistical analysis, analysts uncover patterns and trends that inform strategic decisions. They also create interactive dashboards, making complex data accessible and understandable for stakeholders. Common tools used by data analysts include Excel, SQL, Python, and visualization platforms like Tableau or Power BI. By combining technical expertise with business acumen, data analysts help guide companies toward informed choices and improved performance. Data science and data analysis are closely related fields, but they differ in several key aspects. Data analysis primarily focuses on interpreting existing data to uncover patterns and insights, often using statistical tools and visualization software like Excel or Tableau. In contrast, data science encompasses a broader scope, including data collection, cleaning, modeling, and deploying predictive algorithms, frequently utilizing programming languages such as Python or R. The level of mathematics required for data analysis is generally moderate, centering on statistics and basic algebra, while data science often demands advanced knowledge in statistics, linear algebra, and sometimes machine learning theory. Typical outputs from data analysis include reports, dashboards, and descriptive summaries, whereas data science projects often yield predictive models, automated systems, and actionable recommendations based on complex data sets. Data analysts and data scientists often collaborate closely within organizations, each bringing unique expertise to the table. Analysts focus on examining current data, identifying patterns, and understanding trends that are shaping the present landscape. Their insights help businesses make informed decisions based on what is happening now. Data scientists, on the other hand, use advanced modeling techniques and machine learning to forecast future outcomes. By leveraging the findings of analysts, data scientists can build predictive models that anticipate changes and opportunities. Together, they create a powerful synergy, turning raw data into actionable strategies for both immediate and long-term success. Embarking on a career as a data analyst or data scientist begins with building a strong foundation in statistics and basic programming. typically using languages like Python or R. As you progress, it's essential to master data manipulation and visualization tools such as Excel, SQL, and Tableau for analysts, or more advanced libraries like Pandas, NumPy, and Matplotlib for scientists. Learning how to clean and interpret data is a crucial skill at this stage. For aspiring data scientists, delving into machine learning concepts and algorithms becomes important, often using frameworks like scikit-learn or TensorFlow. Throughout your journey, working on real-world projects and building a portfolio will showcase your abilities to potential employers. Online courses, boot camps, and certification programs can provide structured learning paths, guiding you from beginner concepts to job-ready expertise. By systematically developing these skills and tools, you can confidently pursue opportunities in the dynamic field of data analytics and science. For those aiming to become data analysts or data scientists, following a structured learning path can make the journey more effective. Begin by mastering foundational skills such as statistics, basic mathematics, and programming languages like Python or R. Once comfortable, move on to data cleaning and visualization techniques, which are essential for interpreting and presenting data. Next, delve into databases and SQL to handle data storage and retrieval. As your skills progress, start building small projects that showcase your ability to analyze real-world data sets. Gradually incorporate machine learning concepts and develop more complex projects to demonstrate your expertise. By the time you are ready to apply for jobs, you should have a portfolio of diverse projects that highlight your technical abilities and problem-solving skills.